Okay, we're on lesson 5.0. It's going to be notes, and we're going to talk about all the rules of exponents. The beginning here should be review, but then it's going to get into new stuff real quickly. So we call this the base and this the exponent, and the whole thing is the power. Try not to say but when we have a product of two of the same base, and we're going to add the exponents. So you can see here the instructions are already here. So this is the same base. The base is 5, and we have 2 plus 6 is going to be 12. And note, it's not 25 to the... Did I just add that wrong? I just started a whole video with the wrong answer. So let's erase, and 2 plus 6 is 8, you guys. Because what does this mean? This means 5 times 5, right? And this means 6 5s. Okay, so in the end, there's 8 5s. Are there 8 25s? No, so don't multiply the 5 times the 5 for that. All right, here we have y, so the base is going to be y. 4 plus 3 plus 1. 4 plus 3 plus 1 is 8. Okay, here we have 7 to the power of 1 and 6 to the power of 1. 7 times 6 is 42. Well, why did we multiply those, but we didn't multiply the 5s? Again, this was 8 5s, not 8 25s. And here we have 1 7 and 1 6, and 7 times 6 is 42. And what power is on the y's there? 5 plus 1 is 6. All right, here we are going to multiply. Negative 3 times positive 5 is negative 15. How many x's do we have? We had 2 times 1, so we're going to have a total of 3. 2 plus 1 is 3. And how many y's? We have 7 and 6 make 13. Awesome. Keep going. Quotient. Anytime you divide the two powers, we're going to subtract the exponents. And I'll give an example. But 6 minus 1, what's 6 minus 1? 5. So we have y to the 5. Okay, why do we subtract? Because in the numerator, there's 13 6's. And in the denominator, there's 2. So the first 2 cancel out. 6 divided by 6, 6 divided by 6. Well then, if there were 13 in the numerator, how many are left here? There's going to be 11, right? 13 minus 2 is 11. So we have 6 to the 11. Okay, what about this? 10 and 15. Are we going to subtract those two numbers? No, we're going to divide. So 10 over 15 divides each by 5. So 10 divided by 5 is 2. 15 divided by 5 is 3. The A's. Okay, there's 7 A's on top and there's 5 A's on the bottom. So 7 minus 5 is 2, and the 2 A's are left in the numerator. What happens to the B's? What's 9 minus 9? 0. So there's 0 B's left. No B's, so we don't write it. You could also think of it as 9 B's divided by 9 B's would be the number 1. So that's it for that. We're going to keep moving. All right, everything... Oh, come on, people. Lights, lights, lights. Here we go. Hope you guys can see that. Actually, I want to pause and turn the lights on. Pause. Here we are with the lights on. So we have anything to the 0 power is 1. Any non-zero number with an exponent 0 is equivalent to 1. I'll show you in class another example, but let's just do this, okay? 8 squared is 8 times 8, and 8 squared is 8 times 8. Well, 8 divided by 8 is 1. 8 divided by 8 is 1. 1 times 1 is 1. The other example is 2 minus 2 is 0. 0 eighths. 0 eighths is the number 1. Okay? All of this is to the power of 0. You agree? So what's that? That's the number 1. Anything to the power of 0 is 1. Okay, this is where students mess up. They're going to say that this is 1 plus 5. But that's incorrect. That's wrong. Only the x has the power of 0. Does the 8 have a 0 on it? No. Is this in parentheses? No. So the 8 must stay here. Only the x had the 0 power, so only the x turns into the 1, and this is equal to 8 plus 5, which is 13. You guys, that's why parentheses were invented. if they wanted the if they wanted the 8x to equal 1, they would put it in parentheses, right? But they didn't put it in parentheses on purpose. Okay, this might be new to you. A negative exponent. For any non-zero number a raised to a negative exponent, place the power in the denominator to rewrite the power with a positive exponent. I sing that song from Madagascar every time we see a negative power, that I like to move it, I like to move it. So anytime you see a negative power, we're going to say move it, okay? It doesn't exist on its own. You have to move it for it to make sense. Again, watch out for some in-class examples coming your way in addition to these. So, and why? We're going to say why. Well, do you agree if we were to subtract, we would get b to the negative 3? 2 minus 5 is negative 3. Okay, let's see what happens if we were to expand this. What is b squared? B times b. And what's b to the 5? B times b times b times b. One more, right? Times b. Okay, what happens? B divided by b, b divided by b. We're left with a 1 on top over, now we have b times b times b, but where are these located? They're in the denominator. So 1 over b cubed. So b to the negative 3 is 1 over b cubed. Every time you see a negative, you move it, and then the negative goes away. Okay, that's what it means. 2 to the negative 3, what do you say? Move it. I like to move it, I like to move it. 1 over 2 cubed. And then I ask you, do you know what 2 cubed is? You're going to say, yeah, of course I do. It's 1 over 8, right? How come we didn't do that over here? Do you know what 6 to the 11 is in your head? Nope, I don't either. So we just left it. But if you know what the answer is, write it down. All right. Do you see negative exponent? What are you saying? I like to move it. I like to move it. It has nothing to do with the negative in front. So do you see the power became positive? And we have 1 over negative 3 cubed, which is 1 over 3 cubed is 27, but with a negative, that's going to be negative 27. Because it's negative 3, negative 3, negative 3, right? A negative, a negative, a negative, negative. Okay, flip it over. Here we go. Zoom out. What do we have here? Power of a power. If raising a power to a power, multiply the exponents. And so what's 2 times 8? 2 times 8 is 16, right? So why are we multiplying it? Well, we're saying that there are actually 8 x squareds. I hope this isn't a waste of time. We'll see when we get to the end. So there are 8 x squareds. Well, if each of these have 2 x's, 2 plus 2 plus 2 plus 2 plus 2 plus 2, you get the idea. And that's going to be x to the 16, okay? Can you multiply negatives? Yeah, for sure. We don't need to move these because what happens when you multiply a negative times a negative? We're going to get a positive. Anytime you have parentheses, you're going to make sure you give that power to both terms in the multiplication and in the division. Find the power of each factor in the parentheses and multiply. So, you ready? You may want to say that we're distributing, and we kind of are, like we're giving every base a power. So 3 times, the 4 didn't have a power, so we just gave it a 3. 3 times 3 is 9, so x gets a power of 9. Y has a power of 1, so 1 times 3 is 3, and z has a power of 1, so 1 times 3 is 3. Are any of those negative? No. Do you know what 4 to the 3 is? 4 cubed should be, what is that? Is it 64? I think so. Okay. What about here? We're going to distribute this negative 2. Are you ready? It's going to be fun. Here we go. 7. Does 7 have a power? Just a 1. So we need to give the 7 the negative 2. X doesn't have a power. It's a 1. So we're going to give the x the negative 2. The y already has a power, so we're going to multiply. Negative 2 times negative 2 is positive 4. Now, do you see any negative powers? you may not leave your answers with negative powers, so you need to, I like to move it, I like to move it, okay? 7 to the negative 2 is going to be 1 over 7 squared. What is 7 squared? Good job, 49. Does the x have a negative power? Yes, so where does it need to move? To the denominator as x squared. Does the y have a negative power? No, so it stays in the numerator, and that's your final answer. So step 1, distribute this power. Negative 6 times negative, positive. Negative 7 times negative, positive. 0 times negative 2 is 0. We ran out of room. That's okay. Okay, which ones are positive, which ones are negative, which ones are zeros? That's kind of what you need to do. And we have our beautiful fraction line. Okay, what's positive? What has positive powers? Those are going to stay on the top. What has a negative power? The 6. What is 6 squared? 36. What happens to the 0? Anything to the power of 0 goes to the number 1. So final answer. I'm going to pause and fix it. All right, you getting the hang of this? This gets complicated, but just stick to your little rules, okay? 0 goes to 1, and then negatives go to the denominator. And yeah, we're going to be okay. We're going to be okay. We got this. Just like before, if you have parentheses, you just need to give the power to everything inside. So this would be 3 squared over 5 squared. Do you know what these are? And we're done on that one. Here we go. Next one. 2 squared. A already has a power of 5. So what are we going to do? Power of a power. We multiply. B already has a power of 7. So we're going to multiply 7 times 2. Any negatives? No. Any zeros? No. Is there a power that we know the answer to? Yes. 2 squared is 4. All right, last two. Give everything inside. I think the number one thing students forget is to give the power to the number. So that 2 got that squared. So same thing here. The 3 needs the power of 3. And we could say 3 cubed or 3 to the power of 3. Negative 4 times 3 is negative 12. All over B, 7 times 3 is 21. Are there any 0 powers? No. Are there any negative powers? Yes. So we need to move the A's down. And is there a power we know the answer to? Yes, we know 3 to the power of 3 is 27. Does the 3 move down? Does this move? Nope. It has a positive power, so it stays. And we write A to the 12. I wrote the A in front of the B because that makes more sense, right? A comes before B in the alphabet. All right, that's it. What's going to happen if these are all negative and we're multiplying it by a negative? What are they all going to come out as? They're all going to come out what? Positive, right? Negative 2 times negative 6 is 12. Negative 5 times negative 6, 30. And negative 11 times negative 6, 66. And no numbers to worry about. So that's that. Okay. We're not going to go on to this is pages 1 and 2. Pages 3 and 4 we'll do another time, but just don't lose those, okay? So now what we're going to do is we're going to go into 5.0 practice, and you're going to do all of these. They've just combined the rules, you guys, but don't get overwhelmed, okay? Simplify the numerator and denominator separately. Simplify inside parentheses first, then distribute the power. I'm running out of time, but what is everything with a 0? What does that turn into? The number 1. Right? So don't get frustrated by those. And simplify the numerator and denominator separately. So like the A's, we're going to add negative 3 and 3. What does that make? 0. Okay. And then the inside's already simplified, so distribute this power. So we have A 12, B 12. Okay, what happens to this A to the 0? It's 1. And then just simplify. Okay, when the bigger number's on the bottom, where are the B's going to end up? Here you do 12 minus 2 is 10. but the 10b's need to stay in the denominator because that's where more of them were.